Hi, I'm Dr. Ahmed Abdelal. So now we're going to look at uh, details in terms of how these pleurae work. You need to really study it several times so that it can make sense, because that is really, really critical for understanding how the lungs work and how the processes of inhalation and exhalation work. So you could see here the outer wall here. This is uh, the parietal. See, let's expand it here. This is the parietal wall that lines the interior surface of your thorax, side, all sides and the top beneath your shoulders. And then you have this little layer that is here, that is covering the lungs directly, and that's the visceral or pulmonary pleura. And in between them, when you put these together, there is a tiny space in between them. And inside of that space, there is a fluid that is called surfactant. Surfactant. That surfactant surrounds the lungs from all sides, and it protects the lungs. It's an antibacterial fluid. It is the consistency of dishwashing fluid, like if you the ones that you use to wash with your hand. Very thin, slippery, and antibacterial. And it's a mixture of oil and water. In addition to that, surfactant closes any gaps in between the walls of the lungs and the parietal wall, and it makes it strengthens the suction between the walls, the walls of the lungs and the interior surface of the thorax. So this way, that creates negative air pressure in that tiny space. The space here is called the pleural cavity. Pleural cavity. So again, the pleural cavity and the pulmonary or visceral, the pleural lining of the thorax and the pleural lining of the lungs, or the visceral pleura, when you put them together, both of them have fluid, and so they come together. The space between them is called the pleural cavity, or the interpleural space. Okay, and that space has two things in it. It has surfactant, that fluid, antibacterial, and increases suction, and it has negative air pressure. If you look here exactly, you will see that the pressure inside of the lungs, for example, is the pressure is 760 millimeters Hg. Hg means mercury. And in the pleural space, the pressure is 4 millimeters less, and that is gonna cause the walls of the lungs to be sucked onto the walls of the thorax, the wall of the thorax, so that in effect, the lungs are expanded from all sides. They always remain open, okay? Because the lungs have to always have some air inside of them. If they do not have air inside of them, they collapse. So what is the function of the pleural linkage or the pleural linkages that hold the lungs or make them adhere to the thorax? The main function is to keep the lungs always inflated, to have air inside of them, and that will allow us to maintain them open, and that will allow us to inhale and exhale. But always the lungs must have some air inside of them, and that is only possible through the pleural linkages. So the linkage between the visceral pleura and the parietal pleura is called the parietal pulmonary, or the pulmonary parietal linkage, that is created as a result of getting these two pleurae together, and the space between them has surfactant and it has negative air pressure, and that creates suction, and that suction enables the lungs to remain always open and inflated. The top segment of the lungs, that is under your shoulders, their piece of the pleura that is lining it adheres to the inferior surface of the shoulders, below the shoulders, inferior surface of the thorax. And this area is going to create another linkage. It's called the apical linkage. Apical from apex means the high point. So that apical linkage, it enables the top of the lungs to adhere to the inferior surface of the thorax below the clavicles, and that is going to ensure that the lungs are suspended from above. So when the diaphragm goes down and pulls the lungs with it, that is going to ensure that the lungs do not fall down and collapse. So the apical linkage consists of the superior segment of the parietal of the visceral pleura and the inferior segment of the parietal pleura and the space in between the pleural cavity and the negative pressure and the surfactant in between. That creates the linkage. Now remember, the linkage is not an anatomic structure. The linkage is what happens when you get one pleura, bring it close to another pleura. Like when you have one piece of glass with another piece of glass and put a drop of oil in between and then have the two pieces of glass come together. That will create suction, okay? Will create linkage. So the linkage is a product. It is not an anatomic structure. The pleura is an anatomic structure, but not the linkage. So I am talking to you about something very, very specific, and you must understand it in very specific terms. You cannot make generalized, you cannot understand this material in general terms. It has to be understood in very minute and exact and specific ways. So then the pulmonary link, the diaphragmatic linkage, the diaphragm, the surface of the diaphragm has its own pleura called the the diaphragmatic pleura. It lines up the surface of the diaphragm, and as you could see, the bottom or inferior segments of the visceral pleura, they come in contact with the diaphragmatic pleura. So in between them, there's that gap, the same like everything else. There's that gap called the pleural cavity that has surfactant, and it also has negative air pressure, and that causes the inferior surfaces of the lungs to adhere, to stick to the superior surface of the diaphragm, or the dorsum of the diaphragm. So when the diaphragm goes down, it will pull the lungs down with it, and it will expand the volume of the lungs vertically. The expansion of the lungs through the movement of the diaphragm